Hello students, let's start the first part of flotation. In this part, I'm going to discuss about upthrust, effect of upthrust and buoyancy. So let's start. Upthrust. Before I start for upthrust, let's recall something about thrust. A force acting perpendicularly in the downward direction or in the upward direction is known as thrust. Now, here we are going to discuss about the force exerted by a fluid, say as for a liquid. When a body is partially or wholly immersed in a liquid, then an upward force used to act on it. This upward force used to call as upthrust or as buoyant force. It is denoted as Fb, and as it is a kind of force, therefore its unit is also Newton or kgf. Let's understand more about the upthrust or the buoyant force with an example. Here I'm going to take two different cases for a same kind of situation, and with that I will try to make you understand about the upthrust or the buoyant force. For that, take a bucket full of water. Try to push an inverted glass bottle into the bucket. What do you experience? When you try to push an inverted glass bottle into the bucket full of water, you have to apply downward force. It means bottle experiencing upward force. This upward force exerted by the water on the bottle containing the enclosed air opposes the downward motion of the bottle. Let's understand one more case, case 2. Now take an empty plastic bottle closed with an airtight stopper. Put it in the bucket full of water. What happens? When an empty plastic bottle closed with an airtight stopper is put in a bucket full of water, then it floats in water. Now try to push the bottle into the water. Is it possible to push it easily to the bottom of the bucket? It is not so easy. Why it is so? Because there is a force exerted by the water on the bottle. The force being exerted by the water on the surface of the bottle is called to be as the upthrust or the buoyant force. Now let's understand the characteristic properties of upthrust. Larger the volume of the body submerged in a fluid, greater is the amount of upthrust. Means more the volume of the object is immersed in the liquid makes the body get more buoyant force, whereas less in contact means lesser the amount of buoyant force. More the density of the fluid, greater is the upthrust. This you can understand with the same property what we had discussed in liquid pressure. As we know, liquid pressure is directly proportional to the density of the liquid. Thus, we can say like that the upthrust exerted by a liquid is also dependent on the density of the liquid. The upthrust acts on a body in an upward direction at the center of buoyancy or the center of gravity of the displaced fluid. What is center of gravity? Center of gravity is the point where the total weight of the body is assumed to act vertically downwards. At this point, the body is stable from its either ends. Whereas the center of buoyancy is the point where total upthrust is acting on the water displaced by the submerged part of the body in the liquid. Now, let's see the factors affecting the upthrust. The magnitude of upthrust on a body due to a liquid depends on basically two factors, and they are volume of the body submerged in the liquid and the density of the liquid in which the body is submerged. You can calculate the magnitude of upthrust with a formula: volume of the body submerged in the liquid into density of the liquid. Here is a mathematical proving of this formula. Here you can pause the video and go through the steps. With that, you can understand how we can calculate the amount of upthrust. When you do so, you remember these 2 points. The bodies of average density greater than that of liquid sinks in it. The bodies of average density equal or smaller than that of the liquid floats in it. We will understand this in the next part. Now, let's understand about buoyancy. What is buoyancy? In a very simple way, you can say the property of a liquid to exert an upward force on a body which is immersed in it is known as buoyancy. Or you can say the ability to exert the buoyant force is known as buoyancy. But you need to remember one more thing, that the property of buoyancy is not only for liquids. We can experience the property of buoyancy in any kind of fluid, whether it is a liquid or gas, such as when a balloon is filled with hydrogen, it rises up. This is because of the upthrust exerted by our atmosphere. This buoyancy can be classified into three different classes, which we will discuss when we will understand the law of flotation. With our understanding from all the things what we had seen in this video, we can now say this thing, that the buoyant force is responsible for any body to float or sink. If the buoyant force is greater to the weight of the body, or if the buoyant force is equals to the weight of the body, then we can observe that the body will float over there. Whereas if the buoyant force is less than to the weight of the body, then the body will sink down. We will see all these things when we will understand the law of flotation.